Yanis Alvarez.
Hi, I am Gilbert Buso.
Hi, I am Rex D. Hornelius.
We are about to conduct an experiment about Ohm's law and RC circuits. To start with, here are the following learning objectives. In cognitive, determine the relevance of Ohm's law in discharging the capacitor to light the LED lights.
For affective domain, appreciate the importance of capacitor in a circuit and verify if the resistor works to reduce the current coming from the battery to LED light.
For psychomotor objective, devise and create an experiment that shows how capacitor and resistor works in a circuit.
Ohm's law indicates the linear proportionality of current and voltage that occurs in most electrical conductors. A capacitor is a charge storage electronic device. Their primary function is to store electrostatic energy in an electric field and, where possible, to supply this energy to the circuit. Electrons accumulate on one side of the capacitor during this process and attracts electrons from both. This creates the illusion of continuous charge flow through the capacitor, but flow will immediately stop when the power supply is unable to force any additional electrons onto the capacitor's negative side. The charging and discharging behavior of a resistor-capacitor circuit will be measured in this experiment. Many electrical circuits depend on resistors and capacitors. They are utilized in power supply to produce alternating voltage to direct current voltage for circuit purposes. They are found in spike removers and surge protectors, which protect computer equipment from power surges. Understanding how resistors and capacitors function alone and together is essential for understanding basic electrical circuits.
Now, let's start.
In this experiment, we are going to deal with how important having a capacitor and resistor is in any circuits. Thus, by this, we can know if the capacitor can charge when touched in the battery and discharge it in the LED lights. Also, we are going to look at if the resistor will work effectively to resist some electric current carried by the capacitor to prevent the LED lights to spark, explode, or start a fire.
5 minutes later.
As you can see, if we place the capacitor in the positive and negative terminals of the battery, we are now accumulating charge. When the voltage present in the capacitor equates with the voltage of the battery, the current flowing from the battery to the capacitor will now stop. By this, we can now discharge this accumulated charge from the battery to the LED lights to know if it is working. As we place this capacitor in the wires of the LED lights, we see that it works. When we observe carefully, the LED light did not spark or explode as a natural reaction of any lightings when placed at a higher voltage than what it can only carry. By this, we can conclude that having a resistor in a circuit is very essential to prevent or avoid the harm or fire in our gadgets, appliances, and circuits. Thus, the use of capacitor is also necessary. This will make sure that the current flowing from the source of electricity will not be interrupted.
In this figure, you can see that the wires are indicated with charges, which is positive and negative, to ensure that when the content of the capacitor is discharged, it will flow properly. Thus, the resistor is connected to the positive terminal of the LED to ensure that the electric current flowing is reduced to what the LED can accommodate and to avoid overheating, which may result to fire or explosion. The battery used in the experiment is an 18,500 milliampere per hour or 3.7 volts lithium battery. The reason behind using this kind of battery is because, according to research, it is much safer than the normal batteries available today. The capacitor use has a value of 1000 microfarad and the resistor use has a value of 1 ohm, which are both recommendation of electricians as before conducting the experiment.
Using Ohm's law, we can calculate the resistance, current, and thus power flowing for any given input value. Thus, there are a lot of real-life examples where this kind of scientific idea is being applied to our everyday life. First, in our electric fans, we can adjust the speed of our fans at home by moving the regulator back and forth. The current flowing through the fan is controlled here by adjusting the resistance via regulator. Second, heaters have a high resistance metal coil that allows a certain amount of current to flow through it to provide the necessary heat. So, Ohm's law is also used to calculate the power to be supplied to the heat.
For the real-life application of RC circuit, we can deduce to one idea that the use of camera flash utilizes the concept of the charging and discharging function of a capacitor in an RC circuit. When the switch connecting the capacitor is turned on to the side of the battery, it begins charging. And when the capacitor gets enough charge, it switches to the side where wires connecting the flash function of the camera is. And this will lead to the discharging application of capacitor that will also yield a sudden flash to the light.